Okay, Assalamualaikum warahmatullahi wabarakatuh. We're going to continue on how to solve stoichiometry problem involving limiting. Okay, first we have to know what is chemical reaction and chemical equation. Normally, chemical reaction involve a process which a substance change into one or more substance. For example, A plus B produce C and D, or it could be A plus B produce C, D and E. So it produce more substance. So it's involved with organization of atom in one or more substance, but it have to be balanced. So for example, this one, so we have to know which one is reactant, which one is product. The first thing that appear, okay, before the arrow, and the products that appear after the arrow, what has been formed through the reaction. So number that you have here is coefficients, and here is subscript, and you have here is coefficient. For chemical equation to be balanced, it must have same number of each type. Okay, for example, this one, okay, we have one carbon on the left, one carbon on the right. So we have to consider both. If you have A and B, you have to consider C and D as well. Is it balanced? So you have to check, double check on both sides, how many elements that you have. Okay, for example, one carbon on the left, one carbon on the right, 4 hydrogen on the left, 4 hydrogen on the right, 4 oxygen on the left, 4 oxygen on the right. Then you are alright. So interpretation of balance equation, for example, equation just now, in microscopic level, you can see this is 1 mole, this is 2 mole, 1 mole, and produce 2 mole. But on macroscopic level, it's actually we look at more than mole. We look at molecule as well. For example, this one consists of 6.02 10 power of 23 molecules. For this one, you have to time by 2 because it consists 2 mole and the same molecules. So it have bigger molecule compared to the first one. For CO2, the same things, one molecule for 6.02 times 10 power of 23. But for 2 mole of H2O, those have to be times by number of Avogadro. Now, in terms of gram, is another topic. In terms of gram, also it gives different value of gram. But what you should know, what is the total gram for the reactant? Is it equal to the total gram of the products? So let's say 16.04 grams, okay, plus with 64 grams, that give you 80.04 grams. This is from the total sum of this number from RMM. So you total sum it, so you got 16.04, this is 64, reach 80. And then on the right side, you calculate, it should give you the same amount of products. So step for balancing chemical equation, we must know how to write the unbalanced equation. From the unbalanced equation, we determine the coefficient first, okay, the mole. And then we start with the complex substance and the least complex substance and specify the state of the matter. State is very important because you have to write down, is it a solid with the acronym of S, or liquid with the L, or gas with the G. State. Okay, so look at this one example. Ethane. It's a gas which is burned in oxygen. When we talk about burn, so it's actually plus O2. Plus O2 here to give the carbon dioxide, gas and steam. Carbon dioxide gas, CO2 and steam. Steam is H2O. Okay, steam is simply water in gaseous form and condensed to form water droplet. So write a balance. So you have given here, this is not balanced. Okay, because right, look at on the left we have here, but here is not. So balance first. C2 here, so it could be, you put 2 here, alright, so that's balance for C. And then look at H. H got 6 hydrogen, but this is got only 2, so you time by 3, so you got 3 H2O. Okay, now what we got next is oxygen. Oxygen on the left is 2, on the right is 2, and then here, okay, 2, and here 3. We just added 3 now, so 5, 7, 6. So you can 5, 6, 7. Okay, 5, 6, 7. So now how to do it? You might put 7 over 2. Why you put 7 over 2? Because you want to cancel the 2. Okay, you want to cancel the 2, or you want to bring up the 2. Alright. You can't put here 7. If you put here 7, it's become 14. And then at the right still 6. Okay, 5, sorry, 5, 4 plus this one. Alright, this is 4. Okay, plus 3 is equal to 7. That's why we times by 7. But we put 2. If you put 7 only, you can get this 14. You put 2 because you want to cancel out the 2. Okay, alright, so you put 7 over 2. Alright, so every 2 here, 2 that you put down here, you have to times everything with 2. Meaning this have to times by 2. All these also have to be times by 2. Okay. Alright, so here you can get this one times by 2 as well. So you can get 2, C2 is 6, 18, alright, plus with 7. Okay, 7 is already cancelled out, 2 and 2. Right, and then 4, 2 plus 2 times 7 just now. 2 times 2 is 4, and then 3 times 2 is equal to 6. Now you have this one balance. But the last step, you have to put the state. Okay, ethane is a gas form, oxygen is a gas, carbon dioxide is a gas, H2O is liquid. Alright. So for exercise, I want you to do this exercise, okay, and try it. How to calculate the amount of reactant and products. Okay, we have to know the stoichiometrical equivalent, okay, to the number of mole of any substance. Meaning, coefficient will tell us the mole ratio of the reactant correctly react to. Because of, in the end, we want to know how many gram of the reactant has been produced, how many gram of the product has been produced. Are they balanced at the macroscopic level? So summary, this is a summary, the same thing, mass. From mass, how you convert into mole, okay. And then from mole, how you convert into molecule, or the other way around, from molecule you convert into mole, mole you convert into mass. Okay, from this one also similar. Okay, alright. Okay, this is for compound A, and then you compare with compound B. Okay, for example, this is for a reactant, this is for the product. The same things that you have to do. Okay. Look at these sample problems. You have copper sulfide react with oxygen to produce copper dioxide and also sulfur dioxide. How many mole of oxygen are required to roast 10 mole of copper sulfide? So how many mole of this one? How many mole of this one need to boost up or roast up 10 mole of copper sulfide? So this is given copper sulfide as much as 10 mole. Okay. Right, and then question number 2, how many gram of sulfur dioxide? This one. Sulfur dioxide are formed when 10 mole of copper sulfide is roasted. The same thing, 10 mole of copper sulfide. So we want to know this mole. We want to know how many gram of this. Okay, one is mole, one is gram. Okay. Okay, so the solution is you got 10 mole of copper sulfide times by how do you know this is 3 mole of oxygen and 2 mole of copper sulfide? So basically you have to balance this one because this is not balanced yet. Okay, copper is 2, copper 2. Now oxygen is 3 on the right. Oxygen is only 2 here. So this is 3 over 2. Alright, so 3 over 2. Okay, so you put 3 over 2 because you want to cancel the 2, and then 2 will be times here. Okay, so that's why it has 2 mole of copper sulfide here. Okay, and then this one also can be have to be times by 2. This is also become 2. Alright, so then only is balanced, yeah. Alright, so this one. Okay, so 10 mole of this one is equal to 3 of oxygen over 2 mole of copper sulfide. So that's correct. That will give you 15 mole. Okay. So once you bring here to, there is no more 2 here. Kita dah boleh padam this one. Alright, so no more. Tak nak you confused. Okay. Alright, and then next, how many gram of copper sulfur dioxide are formed when 10 mole of copper sulfide is roasted? The same thing. Okay, 10 mole of copper sulfide times by 2 mole of this one, because it produced 2 here. 2 mole of sulfur dioxide over 2 mole of copper sulfide. Correct. Because it wants gram, you have to times by gram as well. Okay, so copper sulfide, what? This is 32 plus oxygen, Oxygen 16 plus 62, 32 as well, so it's 64, roughly 64.07 if you look at on periodic table. Okay, and then over mole of this one. This is correct, okay, time by that. So you want to cancel, because this one will be cancelled out. This one will be cancelled out. What remaining is gram. Okay, mole here cancel out. So what remaining is gram. So that will give you 641 gram of sulfur dioxide. Okay, simple thing. One is so simple. Alright. So you have to do equivalent here. 2 mole of this one is equivalent to 12 this one. 2 mole of this equivalent to 12 mole of this. Okay. And then next is, oh sorry, terbalik. This is 2 mole. 2 mole of CO2 is equal to, sorry, betul lah, 12 mole of this is equal to 2 mole of this. And then find in 1 mole. In 1 mole, how much you should have, and then only you can times by 4.16. Alright. For next is limiting reagent. Limiting reactant is sometimes when the chemist carries out the reaction not usually present in the exact stoichiometric amount in the proportion indicated the balance equation. This means some reactant will be used up when the other will be left over. Reactant will be used up, we call it as limiting reactant. Reactant that will be left over, we call it as excess. Okay, this is example. You got a box, okay, where you have like a smiley icon and also the glass. Alright, so here when you try to arrange the smiley, 1 smiley per glass, so you found out that 6 smiley can accommodate 6 glass, but you have extra 2 glass here. This is called the balance. This is the product. Okay, the one that being used up, we call it as limiting reactant. The one that being left out, we call it as excess. Okay, right? Okay, if you look at the verb, this one as well, and 2 mole, okay, and 2, 4, 5, 6, 1. Alright, from N2H4. Yes, from N2H4, this one is the less. From N2H4, we compare from here. So it gives you less amount of mole for nitrogen. Okay, that will give you this value. Find the mass. Okay, darab je lah. Darab dengan gram of nitrogen 28.02. Nitrogen is 14 something. Okay, 14.01. Okay, so 28.02. So you get 131 gram of nitrogen. Alright. So next is percent yield. Percent yield is A plus B produce C and D. Alright, so how much we want to know our yield? Okay, reactant is actually, we can use this formula. Percent yield is equal to actual yield over theoretical yield times by 100%. Actual yield is the mass obtained in the real experiment. Theoretical is calculated, that you calculate, okay, you expected. And then percent yield may range from 1 to 100. So 3.65. Okay, this one 3.65 kat sini given over calculated 1 theoreticals times by 100, that will give you 83% of percentage yield. Okay, so same goes to this. 34.6 gram of silver was reacted with sulfur according to the following equation. 34.6. Right. Okay, and then look at the equation, balance or not. Yes, balance enough. So 24.8 of silver sulfide was collected. So yes, more has been react but less has been produced. What are the theoretical, actual, and percent yield? Okay, so same things, mole of this one, 34 over RMM of G is equal to 0.32. Okay, divide by 2. That's represent of equivalent to 2 mole. Okay, equivalent to 2 mole of this. So you have to divide by 2. So you can get this value from mole, and then you convert into theoretical yield. Theoretical yield 0. That value times by RMM plus with 32. This is RMM of who? This is argentum. Argentum is 107.87 times by 2. This is sulfide. Sulfur, 32.06. That will give you theoretical yield. So once you have this, you can find the actual yield. 24.8 over 39.73 times by 100. That will give you 62.4%.